Stimați membri ai Comisiei de Susținere Publică a Tezei, stimate domnule decan, dragi colegi, vă zic bună ziua și mă bucur foarte mult că suntem în așa număr mare la un eveniment foarte important pentru competitorul nostru, deci RAJAT, și îmi permiteți să spun câteva cuvinte. Hello, to our colleagues from Germany. Welcome to Technical University of Moldova virtually. I hope you will soon come to visit us, and let's start our defense today. And I will follow the procedures of Technical University of Moldova and our agency, and I have to read some paper which are in Romanian, but you can include just translate if it's necessary. Am să dau citire extrasului din procesul verbal numărul 3 al ședinței Consiliului Științific al Universității Tehnice a Moldova din 27 februarie 2026, obiect de referință, aprobarea componenței nominale a Comisiei de Susținere Publică a Tezei de Doctorat. În conformitate cu prevederile Regulamentului Instituțional de Organizare și Desfășurare a Studiului Superioare de Doctorat, ciclul 3, din cadrul Școlii Doctorale a Universității Tehnice a Moldovei, metodologiei de evaluare și susținere a tezelor de doctorat la Universitatea Tehnică și în temeiul procesul verbal numărul 1 din 24/2/2026 al ședinței Seminarului Științific al Școlii Doctorale UTM, Consiliul Științific al Universității Tehnice aprobă componența nominală a Comisiei de Susținere Publică a Tezei de Doctorat pentru susținerea tezei cu titlu Rețele, Poroase de materiale hibride, nanostructurate. Specialitatea 13403, fizica nanosistemelor tehnologii de către RAJAT, după cum urmează: Tronciu Vasile, președinte; LUPAN Oleg, membru, conducător; Adelug Rainer, membru, conducător; Buzdugan Artur, referent; Wolfhoff Ștefan, referent; Sprincian Vecislav, referent. Vreau să vă zic că deja avem 4 semnături aici și colegii noștri online care pot să ne confirme prezența lor. Așa că ședința de astăzi este deliberativă și putem începe. Am să prezint teza, deci rețele poroase de materiale hibride, nanostructurate, specialitatea 13403, fizica nanosistemelor nanotehnologii, membrii Comitetului de Îndrumare: Buzdugan Artur, doctor habilitat, profesor universitar; Ababi Nicolae, doctor conferențiar universitar; Crețu Vasilii, doctor conferențiar universitar. Deci, unul din membrii Comitetului de Îndrumare, domnul profesor Buzdugan Artur, este și referent oficial. Așa. Candidatul aspiră la doctor în științe fizice. Deci, acestea sunt. Acum, de obicei, noi oferim cuvântul secretarului Comisiei de Susținere Publică a Tezei, dar odată ce nu mai avem la Universitatea Tehnică în comisie secretar, deci îmi revine mie, deci să citesc lista actelor care sunt prezentate de către competitori. Deci aceasta este etapa a 4-a de examinare și susținerea tezei. Deci teza este prezentă aici, rezumatele avem în limba engleză, în limba română, lista lucrărilor științifice avem, deci avem exemplarele recenziilor care au fost expediate de către recenzenți cu 10 zile înainte de data susținerii. Certificatul academic este aici și deja se finisează cu lista organizațiilor unde a fost expediat rezumatul atât în limba engleză cât și în limba română. Deci toate documentele, aici în regulament spune că se menționează dacă sunt respectate condițiile, cerințele față de credite, publicații și așa mai departe. Deci suntem la etapa de finisare, adică am trecut unitatea primară, avem seminarul științific, de aceea totul este bine, în regulă și, desigur, dacă aveți careva întrebări legate de documentele care au fost prezentate sau cineva din comisie, dacă doriți să vă uitați peste ele, deci noastră deja le cunoașteți, așa că trecem la rubrica următoare. Încă un lucru trebuie să menționez, că avem și, deci, rezumatul de similitudini, la care, deci, avem 2,14%, deci este mult sub 7% sau 6% cât se permite, deci totul este în regulă. Nu-mi rămâne decât să ofer cuvântul candidatului la titlul științific de doctor în științe fizice. Iată și RAJAT, the floor is yours. You have 20 minutes to tell to everybody which is in this room that you can be a doctor in physical science. Okay.
Hello everyone, my name is Rajat. Today I am going to present my joint doctoral thesis with the title Porous Networks of Nanostructured Hybrid Materials in the project Mary's Closed-Cut reactions with a given speciality. The work has been carried out under the supervision of Professor Dr. LUPAN Oleg at UTM and Professor Rainer Adelen at Kiel University, Germany. The content of the thesis has been classified in 5 chapters, starting with the literature review on metal oxide and MOF-based hybrids, followed by my own contributions to the given field. Slides 3 through 6 contains procedural framework which is essential for the doctoral studies in Moldova. The slides are quite dense. I will try to just highlight key milestones to respect the time limit. And to get more information about it, the recorded video session will be provided later. So, starting with the metal oxide gas sensors, which are highly employed due to their robustness and compatibility with the microelectronic fabrication. However, their sensing performance is limited due to its low surface area, poor selectivity and restricted porosity. To overcome these limitations, there are a variety of approaches we can employ, including heterostructure formation, noble metal doping, rare earth metal doping, and so on. One of such way includes metal organic framework metal oxide hybrid systems, in which metal organic framework integration provides abundant and tunable adsorption sites, molecular sealing effect due to high porosity of metal organic framework, and hence analyte accumulation. However, despite the promising MOF metal oxide hybrid structures, there are certain challenges to achieve this, including uniform MOF integration on metal oxides, having stability under adverse environmental conditions, establishing reliable structure property performance correlations. However, to address the research problem, we can understand it in 3 layers, including development of robust MOF metal oxide hybrid structures, followed by the detailed investigation of physicochemical properties, and correlating it with the sensing performance to our target analytes. And the expected scientific outcomes for the developed hybrids include the key enhancement from this work and the underlying sensing mechanisms behind it. Aim of the Christian objectives summarizes the material development for surface enhanced functionality and comprehensive investigation of physicochemical properties to correlate with the sensing mechanism and getting fundamental insights about evolution kinetics. Development of multiple sensor structures for the selectivity, detection of volatile organic compounds and other analytes due to their distinct sensitivity profiles, and try to correlate gas surface interaction mechanistic elucidation by using appropriate models. The key research highlights key novelty of this work includes micro broadcasting, which is low cost and cost effective and easy to use, and for the hybrid system ZIFET copper oxide aluminium, which provides appreciable sensing response towards hydrogen even at high relative humidity of 81%. Using ZIF71 copper oxide aluminium, it exhibits dual gas sensing for N-butanol and hydrogen at different operating temperatures, and using advanced characterization tools, we get insights about phase transitions, thermal degradation and their respective transformation in metal oxides. However, the key primary scientific thesis involves the physico-chemical properties investigation of ZIFET copper oxide-based hybrids to get insights about their structural robustness, defect states, etc. And among all the different variety of hybrids used with the zinc oxide, it gives insights about thermal degradation, phase transition and transformation in metal oxides, which provide information about how the temperature range stable operations can be performed for the variety of sensing applications. In ZIF71 copper oxide aluminium structures, going details for the physico-chemical properties investigation and correlating it with the sensing mechanism. Using this system, it exhibits dual gas sensing for N-butanol and hydrogen at different operating temperatures, and underlying physics behind it, hydrogen selectivity due to molecular sealing effect, and among VOCs due to high electronic polarizability of target analytes. Followed by chapter 2, which includes development process and characterization tools used to perform experiments on metal oxide metal organic framework based hybrid systems. These are the technological developments, synthesis tools, thermal treatments and microdrop casting for the development of MOF based hybrid systems, and the mentioned advanced characterization tools to investigate detailed physico-chemical properties, including Ether 2400 with LabVIEW interface for electrical characterization. This schematic shows the development of hybrid systems, starting with the glass substrate, followed by copper oxide aluminium synthesis using SCS approach, followed by gold IDE patterning for the electrical context, followed by ultrasonication of zip dispersion and micro drop casting of it on developed metal oxides. This is how development of hybrid system was occurred. Chapter 3, it includes detailed investigation of physico-chemical properties and electron transport analysis of ZIF8 copper oxide aluminium based hybrids. Starting with the SCM analysis, here we can see intercrystalline grains of bare metal oxide, followed by development of metal organic framework metal oxide hybrids. Here we can see morphological information of ZIF8 particles. It shows rhombic dodecahedral morphology and the particle size estimation. In micrometer spectra, it provides for non-mode contribution. Here we can see it has been classified in 3 designs. Starting with the blue design, corresponds to lattice framework based vibrations. Green design, it corresponds to stretching and bending vibrations, followed by at high wave numbers, antisymmetric stretching vibrations in imidazolate ring. Now, to get structural features, here we can see XRD spectra, XRD pattern. Here we can see specifically this blue design, which gives highly crystalline XRD peaks for ZIF8, and comparing it with the other reported literature, it shows soda-like topology. And using crystallite size Shearer equation, we can calculate crystallite size. Now, to get insights about the thermal stability, here we can see TG analysis going from room temperature up to 380 degrees Celsius. It retains its structural framework, and then gradually it is degrading with increasing the temperature and transformation in metal oxide. And now to get insights about the absorption isotherm, here we can see even at very low nitrogen pressures, there is a quick nitrogen uptake and then stable plateau, which confirms it as type 1 absorption isotherm, which is associated with the microporous structure. And using this BET equation, we calculated BET surface area. Now to get more insights about the chemical information, here we can see X-ray spectra. The high resolution X-ray spectra gives information about the bonding environment for different entities in hybrids, and copper 2P coming from copper oxide aluminium, it confirms 2+ oxidation state, and zinc 2P coming from ZIF8, its 2+ oxidation state is confirmed through this high resolution spectra. Coming to the application part for the sensing performance, here we can see going from bare metal oxide to developed hybrids, there is appreciable improvement in selectivity for hydrogen sensing, and using dynamic sensing curve, here we can see it gives insights about faster kinetics, and using current voltage characteristics, it shows linear behavior, it follows Ohm's law. But at high temperatures, there is slight deviation from linearity, which could be attributed to the defect states. Getting more insights from the dynamic sensing curves, further measurements were carried out at different times, going from initial measurement after 3 weeks and after 4 weeks. Even after 4 weeks, we can see it retains sensing response for hydrogen at low relative humidity and high relative humidity. It confirms its temporal stability. Even at different relative humidity, going from 11%, 50% to 81%, it shows appreciable sensing response for hydrogen at high relative humidity. It confirms its humidity resistant character. And comparing it with other reported literature, here you can see developed hybrids shows appreciable sensing response comparable to other reported literature, but at very low concentration compared to other reported literature, which gives edge to this work. Even at high relative humidity of 50%, we can see appreciable sensing response. Followed by this chapter, which includes physicochemical property studies about ZIP-71 copper-oxide aluminum hybrids and device integration and its performance for thermoresistor sensing. Here we can see from SCM image partial coverage of ZIP-71 particles on copper oxide and full coverage. It gives insights about the morphological information, rhombic dodecahedral morphology we can see, and particle size estimation. Now to get insights about the structural features, here we can see XRD pattern of developed hybrids. Specifically blue region corresponds to XRD peaks for ZIP-71, which are highly clean, and comparing it with other reported literature, it shows RHO topology. And to get insights about the phonon modes present, microRaman spectra classified in 4 different regimes, starting with the blue regime at low wave number, which is associated with the lattice framework wave vibrations, followed by zinc nitrogen stretching, and in the yellow regime, linker ring deformation waves phonon modes, and at high wave numbers, antisymmetric stretching vibrations in linker ring. Now to get insights about ZIP-71 wave hybrids for thermogravimetric analysis, here we can see going from room temperature to 415 degrees Celsius, it retains its structural framework, and then there is gradual degradation, and at high temperature, its transformation into zinc oxide. To get more insights about absorption isotherms for ZIP-71 wave hybrids, here we can see even at very low nitrogen pressure, there is quick nitrogen uptake and then stable plateau, which confirms its microporous structure, and VET surface area was calculated using this equation. To get insights about chemical information, X-ray spectra we can see surface scan spectra confirms the presence of photoelectron lines associated with the ZIP-71 wave hybrids, and high resolution spectra confirms chemical bonding environment of different species nitrogen. It has 3 different chemical bonding environments, Cl2p, it confirms its spin orbit splitting and deconvoluted peaks, and zinc 2p coming from ZIP-71, its 2+ oxidation state is confirmed. Now coming to the application part, sensing performance, here we can see going from bare metal oxide to ZIP-71 wave hybrids, appreciable selectivity for N-butanol is observed, which was not the case for bare metal oxide, and at high temperatures, hydrogen sensitivity is retained even after 21 days measurement. But at high relative humidity test, we can see there is diminished sensing response for VOCs, and it retains sensitivity only for hydrogen. Why is it so? We will see in the subsequent slide. And here it confirms the synergistic effect of both components from the hybrids. Now, what is the reason behind high selectivity for N-butanol and hydrogen? That we will try to understand through this table. Here we can see, due to small kinetic diameter of hydrogen compared to pore aperture of ZIP-71, it can easily diffuse through the framework, which due to molecular splitting effect, which gives high sensing response for hydrogen. But comparing among VOCs, here we can see they have comparable kinetic diameter compared to pore aperture of ZIP-71. So we have to use another concept. Here we can see using electronic polarizability, N-butanol has appreciably high electronic polarizability compared to other VOCs, which gives information how N-butanol is highly selective for other compared to other VOCs. And to get insights about the defect states, using a Rennes plot, activation energy was calculated, and its association with the whole trap states can be confirmed. Now, to get insights about the corresponding sensing mechanism, here we can see in this temperature range, monoanic oxygen species will dominate, and it reacts to the target and the light. And in different environment, we can see change in band bending and its associated modulation in electrical resistance, which gives rise to sensing response. Now, To understand why is it so in the previous slide, there is only a high sensing response for hydrogen, not for gases at high relative humidity. We can understand using this equation. At high humidity, water vapors, copper sites will make dipolar interaction with hydroxyl group of water vapors, which will tend to decrease the oxygen concentration and give rise to diminished sensing response for VOCs, but not for hydrogen, because hydrogen is non-polar in nature, which will have negligible impact of this. Now, comparing it with other reported literature, here we can see in all the cases appreciable increase in sensing response after making hybrid system going from bare metal oxide, but in our case the multiplication is almost 100 times, which is not the case for the other reported literature, which gives edge to this probe. Coming to chapter 5, which involves physico-chemical properties investigation of variety of ZIFs on zinc oxide hybrids and establishment of its structural property performance correlations. Here we can see SEM images. SEM analysis gives insights about the morphology, rhombic dodecahedral morphology for all the particles can be observed, and particle size estimation. Going to reference sample, here we can see zinc oxide and cadmium dope. Zinc oxide shows columnar grains coming out of the plane, and in case of cadmium dope, additional columns coming out of existing plane due to the cadmium doping effect. And to get insights about the thermal stability, here we can see specifically for ZIF7 and ZIF67, quick thermal degradation can be observed compared to ZIF67 and ZIF71. And to get insights about the absorption isotherms, here we can see for 3 ZIF particles, ZIF71, ZIF67 and ZIF8, quick nitrogen uptake and dense stability, it is associated with the type 1 adsorption isotherm, micropore structure, but not for the case of ZIF7. Using nitrogen absorption isotherm, even at high nitrogen pressures, there is no appreciable absorption of nitrogen in case of ZIF7 because of its restricted pore aperture, and no gate opening effect was observed at low temperature. To get insights from nitrogen absorption isotherm we cannot get, but to do this measurement at high temperature using CO2 measurements, we can get insights from absorption isotherm. And coming to the in situ temperature dependent XRD, it gives great insights about the phase transitions and corresponding transformation into metal oxides. Here we can see going from room temperature to high temperature, its crystallinity is decreasing, decreasing most prominent peak XRD intensity, and at certain temperature its transformation into metal oxide. And in ZIF7 case, here we can see going from 50 degrees Celsius to 100 degrees Celsius, there are additional reflections can be observed, which can be attributed to the release of dispersant solvent molecules, and at high temperatures we can see due to thermal stress there is shift in XRD peaks. And among ZIF71 and ZIF67 particles, at their certain temperature their transformation into metal oxide and lose in crystallinity can be observed. For ZIF67 case, central metal is cobalt, so its transformation into cobalt oxide can be observed, unlike the other cases. Now, to get insights about the phonon nodes, here we can see micro-resonance spectra among these hybrids classified in 3 different regimes, starting with the blue regime corresponding to lattice framework wave vibrations mentioned over here, and in the yellow regime linker ring deformation based phonon modes, and at higher numbers we can see antisymmetric stretching and immodulated ring we can see. Among the hybrid system, X-phase spectra gives chemical information in this photoelectron lines for metal. We can see it confirms 2+ oxidation state for the metals, and about the chemical bonding environment. For instance, nitrogen has three different chemical bonding environment in M3 case and M4 2 chemical bonding environment. And about the spin orbit splitting, we can confirm it using Cl2p based photoelectron lines. Coming to the application part, going from reference sensors to developed hybrids, we can see appreciable sensing response for ethanol was observed at 250 degrees Celsius, which was not the case for bare metal oxide. And among other hybrids, here we can see appreciable selectivity for hydrogen, which is quite appreciable, and among VOCs for N-butanol and 2-propanol, which is quite good. And about the transport mechanism, calculation of Knudsen number using mean free path, here we can see it comes out to be more than 10 in all the cases, which means it falls in Knudsen diffusion regime. What is its physical meaning? The particles and molecules will collide more with the pore aperture holes compared to interparticle collision, and As we have already observed, SCM edges are not continuous, zip layers are not continuous, so contribution may come from defects of grain boundaries, so it will reduce the value of K, but intrinsically we can say it proceeds via Knudsen diffusion, but if contribution is coming from other regimes, so molecular and transitional diffusion may also contribute in their own way. So coming to the sensing mechanism part, here we can see, as we have already observed, this 67 already transformed into cobalt oxide at 250 degrees Celsius. So using this model, as we can see, change in accumulation layer width and depletion layer width can be observed in different environments in air and in the presence of test gas, which leads to modulation in electrical resistance and hence sensing response. Using ionization model, chemoresistive sensing can be explained, can be understood easily as we discussed. And concluding it here, we get fundamental understanding of thermal degradation and phase transition mechanism by doing physicochemical properties investigation of zip particles using zip-fed coperoxide hybrid system zip 71. Using physicochemical properties investigation, we get insights about thermal stability, their operational range, and its use in sensing performance. And by doing advanced characterization, it gives insights about thermal stability and phase transformation into corresponding oxides. Raman spectroscopy provides information about electric stress by shifting the peaks towards higher wave numbers due to cadmium doping. Zip-fed coperoxide aluminum in terms of numbers, even at high relative humidity of 81%, appreciable sensitivity was observed. Low detection limit was observed, which is quite good for even for small hydrogen detection, small amount of hydrogen detection. In terms of numbers, in case of zip-fed based orbits, more than 4 times hydrogen sensing response was observed compared to other VOCs. And zip 71 for n-butanol at 200 degrees Celsius, more than 4 times sensing response was observed compared to hydrogen, and more than 5 times sensing response compared to acetone. And using zip 71 wave hybrids, we observed dual gas sensing at different operating temperatures, at low temperature for n-butanol and at high temperature for hydrogen. So, and these are the scientific results published in different publications. Total publications are 25, out of which 14 are related to thesis and 1 scientific application, patent application, and these are the mentioned journals in which work has been published. Followed by, these are the results that are demonstrated at national and international conferences in different exhibitions, including my industrial internship at ASENS, the certificate, and my adsorption school participation in FAU Germany, and in Hamburg synchrotron measurements at DAISY. And at last I want to acknowledge Professor Dr. LUPAN Oleg, my supervisor, for supporting me throughout my doctoral journey at UTM, and
you
Professor
have this opportunity at the end to say. Okay, thank you, Rajat. Now it's time for questions. Yeah, everybody from this audience, also our colleagues online, please ask the questions, and I will start with one. Okay, if I look on gas response, yeah, within 25 seconds, you have some kind of exponentially grow response. It is nice. On the other hand, if you look for just what is going, then you will have some refractory time. And for example, if I want to repeat this procedure again, I need to wait more 200 seconds and then to repeat. Did you try to get something, okay, exponentially grows and then the decay?
So, we are talking about long recovery. If we will see one example, for example, in the dynamic sensing curves, for example this one, here we can see in recovery time, generally scientifically we take, if it is 90% recovered, so we usually say like it is the recovery time. No, we do not have to wait for 100%, but there could be a drift, like it could be higher than the baseline. It could be due to the presence of defect states, so we could interplay with defects to improve its recovery time. But here we can see it is almost recovered within less than 50 seconds.
Yeah, but you are not going, if you look there, you are not going to the previous state, because you have to wait a little bit longer.
Yeah.
You agree with me, because what you cut it, yeah, but you didn't come back to the
Baseline.
to the base. Yes.
Yeah, that's true. The long recovery time could be attributed to presence of defect state. That I agree. And but what I mean to say, in terms of in scientific terms, recovery time includes 90% recovery. We do not have to wait, but yeah, definitely to get 100% recovery, we have to wait for long time.
For a long time. Okay. Next, my question is on slide 12. You have some linear dependence. Yeah, it's okay. But you said the following, that the defects include some non-linearity. And I observed mathematically these non-linearities. But this non-linearity is so small. This means you do have at least not so many defects in your structure.
Yeah, for example, if you will go to Arrhenius plots, so okay, if you will go to supplementary slides, yeah, here we can see, in case of the paired-based hybrids, we tried using Arrhenius plot. We tried to understand what are the defects, possible defects present. So what we got information from this Arrhenius plot. This is due to whole trap states. So whose activation energy comes out to be around 0.2 electron volt.
Okay.
So slight aberration at high temperatures could be attributed to this defect, or maybe some other possibilities. But what we have done,
they are very small.
very small. Yeah.
Very small. Okay, thank you. Okay, next question.
Yeah, about my question is about the transport mechanism. You affirm that the dominant mechanism is closer diffusion, yeah? But I'd like to know if you evaluate the other contribution of other diffusion mechanisms, especially for more rise temperatures.
Yeah, we did not go to detailed defect analysis investigation, but why I am saying this, because if you will see, these numbers are far higher than 10. So according to this calculation, if k is greater than 10, then it falls in Knudsen diffusion design. And if there will be contribution from defects or grain boundaries, so value of k will decrease. So that's why I am saying, even if it will decrease, so it will take too far to reach to 10. So that's why I am saying most prominently, intrinsically it proceeds by Knudsen diffusion design, but we cannot say 100% it is due to Knudsen diffusion design. So maybe contribution may come from molecular design or transitional diffusion as well.
Thank you.
Okay.
May I ask a question as well?
Yes,
Yeah. Thank you for the quick overview. You used a lot of analytical techniques like SEM, Raman, XRD. Why do you choose these techniques for the characterization of the zip copper oxide aluminum hydrides, for example? Would other techniques be more suitable for advantages and disadvantages of these techniques?
Yeah. Thank you, Professor, for your nice question. Okay. Thank you, Professor, for your question. So, as I understood, what is the advantages of the used characterization techniques in our study? So, for example, if we will see temperature dependent in situ XRD in this case, so it gives us insights about how structures are changing by increasing the temperature, going from room temperature to high temperature. So by doing this, we can get information up to which temperature, if we are using the same damping rate, our structures can be stable, so that if we will do gas sensing measurement for the application part, so we will get the idea this contribution is coming from ZIF, or maybe at higher temperatures we are doing measurements, or maybe it is coming from zip-derived metal oxides. Or if you will talk about SCM analysis, so it gives us information, for example, the morphological information, which morphology it belongs to, and it also gives estimation of the particle size, and among others, for example, TGA test also confirms temperature dependent in situ XRD measurements.
Yeah, if we go back to the SEM slide,
yeah.
So you get a certain contrast. You said, yeah, this is topology. And does the chemistry of the material play a role as well?
Yeah, definitely.
Yeah. So all the question is what kind of SEM images are here? Of course, for the sake of time, you cut it here, which energy you use, and which detector. So maybe you could explain us a little bit which detector it was and why you choose a certain energy and voltage range, for example, for the imaging.
Yeah. Thank you, Professor. So first of all, your primary question was definitely topology and different morphologies play important role in this. For example, we didn't study different morphologies, the effect of different morphologies, but as in the literature review I saw, for different kind of zips, they interplay with the, for example, they are using sulfuric acid modification in the morphology in the literature. So how it affects the sensing performance or maybe other physicochemical properties. So it definitely impacts surface area, which is directly related to sensing response. And if coming to your second question, which detectors we have used, so usually these zip particles are highly insulating in nature, so we have to make measurements at certain applied voltage. These are not that conducting compared to other metal oxides. So sometimes we have to use two different detectors, detector modes, including for example, we made measurements at 15 kilovolts. Also we made few measurements at 10 kilovolts. So it depends. If it is charging a lot, so we have to interplay with the applied voltage. Yeah.
Yeah, one can see, for example, on the left panel, the upper right, the ZIP 71, there's some lines going from left to right through the image.
Yeah, this could be attributed to the charging effect. Here you can see it was showing too much charging effect, and we tried to make measurements multiple times, but we were unable to make similar, like very clean images like other zip particles. But it is maybe due to the charging effect.
And how could you avoid the charging? What would be a possibility at the end to avoid it? Do you have any ideas?
Yes, one thing we tried, because we made a lot of SEM measurements, so we used conducting tape, adhesion tape, so that we can ground the charges. For example, a bit of surface of conducting tape on the surface of this hybrid system and connecting it with the ground. So maybe doing this we tried, and definitely we saw some improvements. But yes, in some cases, even after doing this, we observe charging effect. So one of the possibilities using some conducting adhesion tape, or maybe somehow if we can make our sample more conductive, so this could also reduce, the charging effect.
Usually one can deposit, for example, some carbon layer in order to do this. But it's also a good thing if you bring a conductive material close by, because there's a certain distance over which the electrons, even in insulators, cannot. Okay, thank you. Then we had to study. Then, Raman spectroscopy. So what are the advantages there for the system?
Yeah, thank you, Professor. So, for example, in this case, we also tried for example, it is in supplementary slide, so only for the reference sample, and here you can see. So, it gives detailed information about, for example, if you want to see which particular framework is degrading, for example, and how much it is stable. So, here we can see in this particular region, this is linker ring deformation. So, it also depends upon the intensity of laser we are using. So firstly we tried high intensity for this, particularly for ZIP 67 sample. So it was degrading a lot. this 667 framework, and this particular yellow regime based phonon mode were restricting the intensity. So these were reducing the intensity. So that's why then we try to optimize the intensity. So definitely it gives us insights about how the laser intensity is also degrading zip frameworks, and it also gives insights about, for example, I mentioned linker ring deformation and antisymmetric vibrations for phonon mode. So it gives detailed information about the structures which are not directly can be obtained through XRD or any other structural properties investigation based techniques.
Okay. Yeah.
Okay, thank you, Professor Delung. Other questions? Alte întrebări?
Okay, I have a question over you use another samples for ZIF and zinc single and zinc oxide is duplicate. What is the difference? Because why you investigate zinc simple and zinc duplicate? What's the difference?
Okay, thank you for your question. Yeah, because the slides were too much, so I tried to keep additional slides in the supplementary slides. I will show you there. So, coming to your part. So yeah, these are cadmium doped, for example, micronormal spectra, or if we will go to sensing performance. Here we can see. Going from zinc oxide to cadmium doped zinc oxide, there is appreciable change in sensing response can be observed. See, here we can see in bare metal oxide, it is highly sensitive for volatile organic compounds, but if we will go to cadmium doped zinc oxide, so sensing response for hydrogen is drastically increased. So we can say these, even we used cadmium doping of around 0.2 atomic percent, it had immense impact on the gas sensing performance. Definitely also if we will talk about this Raman peaks, so what we have observed, even for 0.2 atomic percent of cadmium doping, there is slightly rightward shift of Raman peaks towards higher wave numbers, which could be attributed due to the higher ionic radius of cadmium 2+ compared to zinc 2+ sublattice, which will have direct impact, which will create lattice stress. That's why we observe this kind of changes.
And another question will be you investigate zinc oxide and with zinc material and copper oxide, okay? Yeah. And what it will be sensor good for, in your opinion, will be used for before and future?
Yeah. For example, we observe with copper oxide we observe two different kind of zips. One is ZIF71 and another one is ZIF8. For zinc oxide, we try to see the impact with 4 different zip particles. If you will see ZIF8 based results, going to this. Yeah. If you will see, appreciable enhancement in selectivity for hydrogen can be observed for ZIF8 case, and also high sensing response for other VOCs. But among VOCs, we observe for n-butanol it shows high sensing response, and among all for hydrogen. If we will go to zinc oxide sample, here we can see. In this case, it is ZIF8. High sensing response can be observed, but at 200 degrees Celsius, we cannot see any sensing response for other VOCs. Even at 250 degrees Celsius, negligible sensing response. So here we can see, even at 200 and 250 degrees Celsius, in case of ZIF8 copper oxide hybrids, we saw appreciable sensing response for VOCs, but not in this case. But definitely for hydrogen, in both the cases, it shows high sensing response.
Okay. Yeah.
So, you know very well, when you started this project, this material was new, but last year, 2025, it was awarded Nobel Prize for metal oxide framework.
Yes.
And the press release was written that this material can be used in a lot of new applications. Which applications you can propose from your thesis after your research?
Yes. Thank you, Professor. I think it is a very hot topic to discuss about metal organic frameworks, as Professor mentioned, and definitely it has immense applications, lot of applications. So, from our studies, as we have observed, If you will go to X-phase spectra, project 71, I can explain it by giving an example. So, there is a presence of Cl2p, that is chlorine functional group in case of ZIF71. So, ZIF71, it has chlorine Cl functional group, which is highly polar. So, it has direct impact of X-ray exposure, so it degrades and there is a radical formation occurs. So from this we get insights that it can also be used for radiolytic detection, and even for example there could be a small intensity of XRD may harm lot of microorganisms and so on. So it could have immense great amount of opportunities in this particular field, and apart from this we can also say it has a great potential in catalytic industry, and also most importantly Professor Omar Yagi, he was involved with he got Nobel Prize last year for the development of metal organic frameworks. So he has a startup, he is working on what you can say, even in the desert areas, how to harvest water even at very low relative humidity. If we will see, even in desert areas, relative humidity is not 0%. We have 10%, 11% or 8% relative humidity. Even in this relative humidity, using this high surface zip particles, they are using it for water harvesting and employing it for variety of applications, so that people can get advantage of this thing. So I think it have immense amount of applications. So thank you for your question.
Yeah, the question was which applications from your research? So one is
radioactive detection and definitely gas sensing performance from this we can say, and also if we will go to in situ temperature dependent XRD results, we saw at which temperature it starts degrading. So it also opens up variety of application based studies, so we can also get insights to go through other applications using this physicochemical properties results. Yeah, thank you.
Okay, mai sunt întrebări?
Excuse me, I have lost my voice. I have one question.
Wait.
Sorry, Professor. Can you please repeat?
Yeah, just wanted to say hello and thank you for the nice talk.
Yeah.
Okay. So my question is based on your research. Could you state some features that gas sensors should have? Like for example, let's say good thermal stability and withstanding different situations with varying humidity, and based on your research, how to design the properties of the sensor, in particular the microstructure, to obtain these superior features or properties.
First of all, thank you, Professor Stephen, for your nice question and for joining us today. Definitely I will try to answer your question. For example, here we can see using zip at copper oxide and aluminum wave hybrids. Talking about temporal stability. So here we can see we tried it 3 times. After 3 weeks measurement, after 4 weeks measurement. So talking about how temperature and multiple measurements after some time it impacts the sensing performance, definitely the structural properties as well. So we saw almost same sensing response was observed. So it shows it can retain its sensing response even after 4 weeks measurement. Definitely it is not long-term stability test. We will target it in future. But if we talk about in humidity, different relative humidity, going from low relative humidity, high relative humidity, even at 81%, it shows appreciable sensing response. So in adverse environmental conditions, in different relative humidities, in different temperatures, we observe it can retain its structural framework. But there could be a possibility in where we can improve is, I think, as I already mentioned, exposure of X-rays. So while we are doing XRD is I think not too much highly intense, but in specifically in XPS we have to optimize before doing measurement. For example, we are doing measurement for long time, so we will see after first measurement we saw different properties as compared to after doing the measurement second time or third time. So it may have impact of X-ray exposure. So we have to chemists should have to look at the impact of X-rays on the structural properties and other morphological properties, so that maybe it definitely if it is highly sensitive towards X-rays, if somehow we can make it more robust even towards high X-ray exposure, or if not, so definitely it could have not in sensing performance, gas sensing performance, but it have great impact on X-ray sensing, X-ray exposure. So yeah, that is what I can comment on this. I hope I answered your question. Hello?
Thank you.
Yeah. Thank you, Professor.
Yes, thank you. And one question.
You can read it.
You can read it.
Yeah.
Voice is lost.
Thank you, Professor. So how many publications do you have on the topic? How many?
You can read them loud.
Yeah. So Professor Vesisla asked, how many publications do you have on the topic of thesis, and how many for the
one application?
Yeah, how many for each different applications? So yeah, thank you very much, Professor, for your nice question. As I tried to make it in limited time, I think I didn't give too much time to this particular slide, but yes. So yeah, in this slide you can see total number of publications are 25, out of which on the topic of thesis I have 14 publications, including in different international journals, in international national conferences. One we can see in just like national repository from Moldova, and one is requested patent that I applied just last year. So these are the publications, and about the international journals I try to highlight it in red color so that like we can get insights in which journals the research work has been published. I hope I gave the answer.
Thank you, Rajat.
Yeah.
Mai sunt întrebări? Dacă nu sunt întrebări, ok. Rajat, now we will switch to another point which I have to present here, what questions you got from department and from the seminar. Yeah, and it's in Romanian and it's prepared, I hope, by you. Yeah. Stimați colegi, deci avem tabelul de sinteză al obiecțiilor și recomandărilor la teza domnului Rajat de la Departamentul Microelectronică și Inginerie Biomedicală. Deci, domnul profesor Buzdugan deci are câteva propuneri de ce nu au fost efectuate teste de stabilitate pe termen lung, mai departe condițiile de depozitare a probelor dezvoltate și iarăși, deci profesorul Trofim, mecanismele de detecție propuse reprezintă modele originale sau sunt teorii consacrate. Mai departe, domnul Buzdugan a menționat și domnul Vasile Crețu, concluziile la capitolul al doilea lipsesc de la sfârșitul acesta. Deci aici avem tabelul de sinteză și avem anexa la care sunt propunerile de modificare și reprezintă soluțiile pentru cei ce a fost la Departamentul de Microelectronică și Inginerie Biomedicală. Deci toate modificările care au fost propuse de la catedră au fost luate în considerație. Acum, ok, Rajat, you will answer. You understand me, yes? Because here, not yet. Okay, here some suggestion from department, which comes from Professor Buzdugan, from Professor Trofim, and Associate Professor Vasile Crețu. Did you include all of them?
From the previous thesis, yes.
Yes, from previous thesis, and they are here in this paper.
Yeah.
And now I'm reading the Annex 2, which you prepared from the seminar.
Yeah.
Yeah, and the suggestion comes again from Professor Buzdugan, Professor Sprincian, and Professor Serghei Răilean. And here I already in Romanian, o creștere a umidității relative ar trebui să tindă să scadă rezistența senzorului, unde se află această informație. Okay, here it's indicated where this information is included. Deci, domnul profesor Sprincian, concluzii din capitolul 1 duc lipsă de argumente riguroase privind necesitatea cercetării. Did you include concerning why it's necessary your thesis for our community?
Yeah.
What the Professor Sprincian suggested. And then we have Sergiu Răilean, which indicate spațierea marginilor din teze apărut a fi mare. Did you exclude? Because now it's S3 left, 1.5 right, 2, 2.
Yeah, I try to follow the guidelines.
Yes.
As per the
Everything it's included. Da, deci aici este localizare în teză, chiar avem indicații, capitolul 4, pagina numărul 75, capitolul 4, capitolul 4, pagina 71, acum avem capitolul 4, paginile 68, 80, 81 și în întreaga teză a fost modificată spațierea marginilor acestei teze. Bun, deci dacă aveți întrebări, no. No questions, then, okay, you have to answer, but you confirm that you included all of them.
Yeah.
Yes, in the thesis which you will send to one to the library, our library, another to the main library of the country. Okay, next point, I have to give the floor to your boss, but I will shift this and I will offer at the end. Da? Okay. Yeah. Now we switch to the references official references. First, I have to give the floor to the person which care este domnul Buzdugan. Da. No. In accordance with the reglement, I have to give the floor to the person which was in the group of for pentru drumare. Bun, vă rog.
Okay. Honored Council, dear colleagues, from the beginning I would like to mention that this is the third my reference for the given work, because as the internal evaluation, as the scientific seminar of the profile, I was also nominated as the referee. Thus I don't think it is appropriate to repeat the general part of the review. I note generally that this is valuable contribution to solving the scientific problems related to obtaining by simple and relatively cheap technology of metal oxide micro and nanostructure and hybrid structure with zeolitic mixolis, with sensory properties for a series of gains, then complex investigation and elucidation of the mechanism of gas surface interaction. I want to mention that the correspondence of the technical content of the approved topic publication and abstract and general conclusion reflect the stated topics and the main result are presented in the abstract and the respective publication of the author. My minor objection and suggestion is regarding the presentation of the text when I note some grammatical errors as well as a minor deviation and bibliographic references, for example 1.8 to 3.8 for the respective university regulation. Also, there are some repetition of text in the original chapter, for example the transformation of adsorbed oxygen molecule into variety of ionic oxygen species depending on temperature is indicated twice in equation 3.14 and also in equation 5.45.7. I'd like to underline that this text errors do not influence the scientific and innovative result of the thesis. In my conclusion, I evaluate the thesis as excellent, and from my generalization set out above, I recommended the award of the doctorate in physics and science of Technical University from Moldova. Thank you.
Thank you very much. So, Professor Buzdugan, and I'm addressing to Professor Vulkov Stepan, Doctor, Engineering Professor from University of Kyiv. Can you hear us?
Yes.
Okay, please. Yeah, now we can hear you.
Right.
The floor is yours.
First round.
Okay, yeah, thank you very much. So I give you a short overview of my evaluation of the thesis. So it's a quite valuable thesis, which focuses essentially on developing hybrid metal oxide materials for gas sensors. Yeah, we've seen that we get improved, or we've seen improved selectivity, tolerance against humidity and stable operation under varying environmental conditions. So, in this sense, the thesis provides a comprehensive and up-to-date review and further extension of already established theoretical insights. It also provides important structure, property relations, and models to explain the sensing mechanisms. I would also like to point out that the work introduces innovative sensor designs and achieves selective detection of gases such as hydrogen and VOCs with high sensitivity and stability. Overall, the thesis demonstrates a really strong scientific contribution and practical relevance from my point of view. And this is supported in particular by the numerous publications in high-ranked international journals and patent. I have, since it was explicitly asked for, also some minor suggestions. Let's reduce it to one suggestion. And that suggestion is related to the recommendations given rather versus the end of the thesis. So here one could envision more innovative possible directions for future research and investigations resulting from the thesis core findings. Overall, the thesis was really nice to read, and I suggest also the grade excellent.
Thank you.
Okay, thank you. Okay, did you respond? Because it was a question.
Yeah.
Yes.
First of all, I want to thank all the official reviewers for the wonderful suggestions. Regarding the questions from Professor Arthur Buzdugan, if I'm wrong, please correct me. The first question was regarding to the references, was not related to the guidelines and minor deviations, minor grammatical errors in the presentation. So definitely I think if you are referring to the previous presentation, definitely I tried to make some modifications in the grammatical errors, what I also found. And about the references, I don't know which particular reference you are talking about, but there are few references I took to explain the theoretical framework. For example, how SCM works, about the operational principle. I took the references from the books from 1960s, 1950s, in which I cannot put DOL numbers and everything. I just try to make the book number, book name, and about the volume. But yeah, maybe I will try to see like if I can make possible modifications so that it will fulfill the requirements of methodology and guidelines from UTM. And about your second question, that was related to sorry?
Some numbers, some text.
No, one was about the references,
Yes.
and the second...
About the, I remember just. The second was about the repetition of equations. So there is one point in the third chapter, as you mentioned, and as compared to fifth chapter, they have different types. For example, copper oxide is P type, and zinc oxide in chapter 5th, it is N type. So other rest of the equation is same, but in copper oxide there was a mentioning of holes, and in the chapter 5th there was a mentioning of electrons. So there was that difference. That's why I tried to not to confuse the people, so that's why I make it in different equations. But for chapter 3 and 4 I try to combine it because both have P type metal oxides. So yeah.
Okay, and now we switch to our colleague, Professor Sprinchan.
About the possible explanation for Professor Stephen's suggestion. Yeah, definitely, Professor, in the recommendation section, we can explain more like what are the possible applications we can think of from the studied samples. Definitely, a few I tried to explain: radioactivity detection and how it can contribute in the sensing performance. Definitely, I can add more possible applications which can support our results. So yeah, definitely. Thank you for your suggestion.
Okay, thank you. I give the floor to the Professor Sprinchan. He is present here. Unfortunately, he cannot speak. Yes, and he gave me some medical problems, and he gave me the review, and I will try just to follow it in few words. Review regarding the evaluation of doctoral thesis, and the name of RAJAT, and then start theoretical basis of this thesis. The problem addressed in this thesis related to the development hybrid structure based on metal-organic framework, scientific innovation and originality. The thesis is based on the development hybrid materials based on nanostructure, something zinc-O, using a simple and cost-effective approach. The practical value of the research, the development of a hybrid system was demonstrated using synthesis from chemical solutions, methodological quality of the research, here are some points, and the conception quality of the text. Let me read a few words about this. The text on the thesis is presented in an appropriate language. The sentences are clearly formulated. Bibliographical assurance, bibliography presented in the thesis contain a large number of resources, 274, too much from my point of view, but in any case, some of them started from 1967 to 2026. And the quality of the thesis offers the following recommendation from the possibility of using the obtained results and objectives and suggestions. There are also some shortcomings in this thesis which its principle do not affect any main aspect of the thesis. Among them I could mention the following. In the first chapter of the thesis, it is not necessary to give the overview of characterization tool and the principle of operation. Okay, on page 25, fig. 1.2, the schematic illustration of structure and corresponding energy band diagram is shown, which has no connection with the topic of the presented thesis. In chapter 3.4.5, Y-share equation has been used through it holds good for particle size less than 100 nanometer. In the developed hybrid structure, there is no uniform layer of ZF on metal oxide structure. Why aluminium doping is chosen for copper-based structure and how it is contributing in gas sensing. Okay, you have to, because you got all this stuff 10 days before your defense and you will respond to them. The graduate awarded very good, and I recommend to confer the joint doctoral degree, Doctor in Physical Science at the Technical University of Moldova. Okay.
Well, thank you, Professor. Thank you for your nice suggestions. And about the questions that you have asked, I will try to answer. There are 5 questions, if I am not wrong. First question was related to including the theoretical concepts about the different physicochemical tools that we have used, for example, SCM. I try to keep it in chapter because what I understood going through this doctoral journey. For example, if I am going to do SCM measurements or micronormal measurements, so being a student of physics, I'm always curious to understand like how these apparatus work and what is the working principle behind it, and what are the components that we are using, and try to understand the underlying physics behind it. So that's why I try to make it in one particular chapter about the literature review, so that whoever will read this, so they will get insights about the theoretical concept behind it as well. And about your second question, which was related to keeping one band bending diagram in literature review, which was not related to topic of thesis. Yeah, I think if I'm not wrong, that is about the photo detection. That is not the core study of our thesis, but definitely, because I try to make this matter organic frameworks application more generalized, so I try to mention some applications which are not just related to sensing, but how matter organic frameworks can also be used in different applications. That's why I try to give one example of one conductive move, how it can be used in photo detection applications. And about your third question, if I'm not wrong, it was related to using Scherer equations in different chapters, going from chapter 3 to chapter 5. Yes. If you will see, like I have already
okay, you can tell by words.
Yeah. For example, in chapter 3, Z-FAT particle size was 70 nanometer, which was less than 100 nanometer. So definitely, as per the literature, there is very less possibility of high errors. So up to 100 nanometer, around 100 nanometer, it can give appreciable results for this. So Scherer equation can hold good, at least for chapter 3 Z-FAT particles with the current particle size. And about other particles including ZIP67 and ZIP7 particles, they also have around 100 nanometer, one have 170 nanometer particle size, one have 200 nanometer. So there is no too much error of margin. So I try to give that example like how we can calculate, but definitely there might be a larger contribution of errors compared to ZIP8 particle study. But in this crystallite size studies, I have already mentioned in thesis as well, and already mentioned in by demonstrating my work in slides as well, like it is a coherent diffraction domain size, it is not the particle size, so it shows the ZIF particles have polycrystalline nature, so particle size is higher than coherent than crystallite size, so crystallite size shows it has coherent domain contribution and particle size is showing the overall contribution, but definitely for ZIF 71 particles their size is around 500 to 750 nanometer range, so I tried to exclude it. So in the current state of the thesis I have excluded, even in the slides as well, shear regression concept in chapter 4. And about the question number 4, it was...
It's enough, yeah. In the developed hybrid structures there is no uniform layer.
Yeah, so as I've already mentioned in my slides and definitely detailed in thesis as well, so as I mentioned, Professor also pointed it out, intrinsically there is a contribution from nuts and diffusion regime, but through defects of grain boundaries there might be a contribution from 2 other regimes including molecular regime or transitional diffusion regime. So in this study I tried not to be more, I tried to be conservative so that it is not 100% from nuts and diffusion regime, but there might be a contribution from defects or definitely from other 2 regimes. And about comment number 5th, this that was a question related to how aluminium doping was used and how it is impacting the sensing performance. Definitely I think it is a nice question. In my current work I didn't study the effect of doping on our sensors, but the already published results from copper oxide aluminium, our senior researchers have already worked on it. I tried to take it as a reference and I tried to check the effect of ZIF layers, different variety of ZIF layers, ZIF 8, ZIF 7, ZIF 67 and ZIF 71, how it is impacting the existing gas sensing response from the bare metal oxides. But definitely if we will go, definitely I read the papers, already published papers from our senior researchers. The aluminium can impact, for example, aluminium ionic radius is less than original copper sublattice ionic radius, so it will try to restrict the grain size or crystallite size of the overall film, so it will influence directly the conductivity so that it can directly influence the sensing response too. So definitely we can say it will have impact, but it was not the core study of this work. Thank you.
Thank you. Sunteți satisfăcut de întrebări răspuns, domnul Spâncean? Da? Bine. Da. Acum trecem la următoarea rubrică. În afară, deci, membrii comisiei, dacă cineva dorește să se expună asupra tezei, deci o puteți face acum, cei care au citit teza. Sper să spuneți câteva cuvinte. Dacă nu este, atunci... Okay, now it's time that each member of our commission has to present few words about thesis and at the end to tell us concerning the final mark which we have to include, because we already gave some marks which didn't include the presentation, and after presentation we have to give the mark which will be included in our document here. And we will start with our colleagues from Germany, and I will give the floor to Professor Adelung.
Yeah, thank you very much. I think it's already said that the thesis addressed a highly up-to-date and relevant topic in gas sensing, and that there were a lot of very important publications shown, and impressive publication record, some patents, so demonstrates clear improving selectivity under Yeah, strong aspect is the impressive amount of experimental data, and also up-to-date analytics was used. Yeah, in the outlook, could maybe also suggest some more about, for example, combination of sensors, but overall I would say that this work is yeah, very good to excellent grades, which I have also to write down. So I would propose a very good as a grade for the exam.
Thank you. I included here very good, and the floor is given to Stefan Volkov from Germany, from University of Kiel.
Yes, thank you. Yeah, so I think the thesis is a very good scientific innovation and originality, and we've seen a clear practical value of the research from a methodological point of view. It was also very high quality that we have seen. The quality of the text was also very good. Could be a little bit more in-depth in places. We've seen a very good bibliography overview also. And I think the strongest part of the thesis and the strongest result, even from my point of view, is the very strong publication record. We've already heard about this. I already recommended excellent for the written part, and I would like to keep this grade also after the presentation.
Thank you very much. Okay, now we start from the left side and come to the right.
So in my opinion, this is a complete thesis. It contains all required parts, chapters. It has 3 major chapters with a lot of experimental data, all data supported by published publications in peer-reviewed journals. Each review, we know that it takes several rounds, so it was really a long period. From the beginning, I did not expect it, but we will come to a positive finish, but it looks we made it in 3 years, a lot of research, because he started to work hard and followed all these steps of peer review process, included analysis of literature was done really during the whole period of PhD and published in a peer review, in a review paper, yeah? It was published in a good journal, Materials today. So, in my opinion, thesis is excellent, and for other parts I give marks between very good and excellent, but general one is excellent.
Okay, thank you very much. Okay, you gave the mark already. Your mark is foarte bine.
Very good.
Very good. Okay. Domnul profesor, câteva cuvinte și...
Da, mulțumesc. Deci, da, am repetat deja de 3 ori. M-a impresionat teza, este teza excelentă, în opinia mea. Într-adevăr, au fost unele obiecții la primele faze de evaluări, dar competitorul a luat toate în considerare și a introdus redacțiile necesare. Deci, un studiu a structurii absolut noi, cu metode avansate, care a permis să elucideze fizica proceselor și să recomande și niște dispozitive care pot fi aplicate practic în perspectivă. Evident, volumul de lucru este extrem de mare pe structuri noi și recomandarea mea de ulterioară este să mergeți în această direcție, fiindcă are foarte mult de făcut în continuare cu studierea acestor materiale pentru noi aplicații, nu dar a inclus și careva proprietăți optice acolo, fiindcă domeniul de aplicare nu este numai senzorica, dar sunt și multe dispozitive optoelectronice în perspectivă. Notarea mea rămâne, teza este excelentă.
Okay, I will tell a few words concerning thesis, concerning resume, and I like this thesis. By the way, I like to work with RAJAT always. He came to me. Sometimes I work as a translator for him in main building of Technical University. But really, it was pleasure for me to work with him, and only I complain one thing, that the number of bibliography of references is too huge, I mean too hard, very big. But I introduce here the mark very good, foarte bine, and now we are the following. We have 3 excellent and 3 very good. And we have to go, I have to introduce in the decision, I will read the decision, but not before we look which one have to be introduced, because we have to select and to vote. I observe here that from referee, I mean we have 2 excellents, 1 very good, and also from Oleg Lupan and Adelung are very good and excellent. And how we proceed in such a situation? Usually we gave the opportunity to our agency if they consider they can increase. But this is not fixed in law. Adică noi oferim posibilitatea, adică am putea să mergem foarte bine și ei să ridice la excelență. Or we can go with excellent. Okay, Professor Adelung, what is your opinion?
Yeah, as it is a joint degree, if we would go by excellent, we could not do it in this round, because then we would need a selected external reviewer again for the thesis. So in our scales, if there's only 1 or 2 very good under the excellent grades, it would be less than summa cum laude. So that is a simple technical problem we have here, which I see.
În Germania, dacă măcar unul e foarte bine, nu se poate dat excelent.
Măcar unul,
Măcar unul, dar noi 3.
Okay, we will follow the rules which are in your country, and we have also something like this. What I said, we gave the opportunity to the agency, and because at the agency there is a big committee, and this committee will look, or they will see what was here and so on. This means we will go to the agency with mark very good. Yeah, this one is clear. Now I came to the decision. This is a draft, and I have one example which is in English and another one is in Romanian. I have to read it because everything is registered here in Romania. Yes, and I will not follow all this decision, deci dar trebuie să citesc hotărârea Comisiei de susținere publică a tezei de doctorat din cadrul Școlii Doctorale a Universității Tehnice, specialitatea 13403, fizica nanosistemelor și nanotehnologiilor, cu tema Rețele poroase de materiale hibride nanostructurate, conducător științific LUPAN Oleg, doctor habilitat, profesor universitar UTM și, trebuie să fie din rând nou, este din rând nou, și Adelung Rainer, doctor National Professor, Universitatea din Kiel. Evaluând conținutul tezei elaborate și prezentarea domnului RAJAT, membrii Comisiei de Doctorat apreciază lucrarea ca fiind una de o valoare științifică incontestabilă. Teza și autoreferatul sunt structurate și prezentate conform exigențelor stipulate în actele normative ale ANACEC. Actualitatea și importanța problemei. O scădere continuă a calității mediului ambient poate fi observată ca urmare a unei combinații de activități umane și factori naturali. Pentru a aborda această problemă, cercetătorii au dezvoltat materiale noi. Progresele în proiectarea materialelor prin utilizarea hibrizelor care combină oxizi metalici și structuri zeolitice de tip, da? Păi știu, dar tot trebuie să citesc măcar câteva fraze. Noutatea științifică. Lucrarea prezintă dezvoltarea unor materiale hibride bazate pe sisteme nanostructurate. Comisia, deci, are această decizie. Valoarea aplicativă. Analiza comparativă a stabilității termice a oferit o foaie de parcurs fundamentală pentru degradarea termică în cadrul sistemele MOF-MOX, problema științifică de cercetare. Problema soluționată prin prezenta lucrare constă în depășirea limitelor senzorilor clasici pe bază de oxizi metalici. Concluziile. Comisia de doctorat remarcă volumul mare de muncă, buna sistematizare și interpretare a rezultatelor obținute în teza domnului RAJAT. Teza este de un nivel științific înalt, confirmat și prin faptul că rezultatele cercetărilor efectuate de autor au fost publicate în reviste, deci științifici cotate ISI și Scopus. Trebuie dimenționat în mod deosebit că competitorul are la moment indicele Hirsch 5. În concluzie, conținutul tezei, modul de abordare, noutatea științifică a rezultatelor cercetărilor și cercetările teoretice și aplicative. Teoretice, nu știu, trebuie scos. Teoretice n-am văzut teorie aici. Deci, teoretici scot, cercetările aplicative efectuate sunt elemente esențiale și motiv pentru care considerăm că teza de doctor a domnului RAJAT corespunde cerințelor Agenției Naționale de Asigurare a Calității în Educație și Cercetare Republicii Moldova și specialitățile 13403, fizica nanostructurilor și nanotehnologiilor. În conformitate cu cele expuse mai sus, Comisia de susținere publică a tezei de doctorat din cadrul Școlii Doctorale Universității Tehnice hotărăște a se atribui calificativul foarte bine. A conferit domnului RAJAT titlul științific de doctor în științe fizice, specialitate 13403, 13403 trebuie să treacă de nou, deci fizica nanosistemelor și nanotehnologiilor. A solicitat Agenției Naționale de Asigurare a Calității în Educație și Cercetării aprobarea hotărârii Comisiei de susținere publică a tezei de a conferi domnului RAJAT titlul științific de doctor în științe fizice la Universitatea Tehnică a Moldovei și eliberarea diplomei respective. Întrucât teza a fost elaborată în cotutelă, solicităm, după caz, eliberarea de către UTM a unui certificat și a unui supliment la diplomă care confirmă studiile în cotutelă cu Universitatea din Kiel, Germania, în baza acordului de parteneriat. Professor Adelung, I discussed with the people at the Ministry of Education, and they agree that we will give to RAJAT a certificate which will be signed by our rector, by me, and also we can include the Ministry of Education in this certificate. And we will give him also the supplement of diploma. Yeah, okay, this one it's done, but only we will do this after the agency will accept all our documents. Okay, this is what I have to inform. Pentru conferirea titlului științific de doctor în științe fizice a Moldovei, Comisia de doctorat în prezența a 6 membri, deci punem 6 membri, din numărul, stai, dar cât suntem noi? 6. Da, 6. A votat în felul următor. Ok, now it's time to vote. Who is for this, what I read? Just, let's vote. Haideți să votăm membrii comisiei. Trebuie să votăm. Votăm.
Eu ați spus acolo că e 3 pe 3. Aici ce?
Ați scris foarte bine.
Foarte bine.
Da. De dacă la dâns și la noi tot, adică dacă măcar unul. Bine. Da, da. Bun. Ok. Cine este pentru? Ați votat și dumneavoastră, da? Da. Ok. And from Germany, 2 votes. Ok. Thank you. Stefan?
Sorry, I'm not sure what I'm voting for.
Did you vote for? We vote for final mark, which is very good, and for the decision which you got on your email.
Okay.
Yes.
Yeah, then
Yeah, this one, we need to vote. This is a requirement from our agency. Okay. Thank you. Da, pentru.
We have also from Germany one requirement, which is commitment. I can maybe in Romanian translated put this in the chat, and if RAJAT is then before somewhere in the process kind of could read that, that would be very beneficial.
Okay.
So read it.
Okay. Okay, now it's time.
O propoziție. Trebuie să citească propoziție cei care au scris-o din Germania, că el va să respecte etica științei.
Okay.
Asta e cerință în Germania.
Yes.
So you have to read it and you'll be on video.
I can, Oleg, should I send it by email? I think.
No, you can insert in chat here.
Okay.
You have chat on top. On top.
Asta e acum aici te la medicină.
Da.
Deci ei tot au așa.
Chat on top. You see on top, you have chat here. See on top. Click on chat. You explain it.
Only share.
You can share your screen. Share the screen.
Okay, give me some. Then I
Type something.
make it as a slide. Yeah, or I have a better solution. Yeah.
Read
So
it.
this is the commitment
Yes, Rajat.
in English.
You have to read.
Yeah, so I'm reading on behalf of Professor Edison. I commit myself to honor the academic degree which will be awarded to me by the faculty. I also commit myself to search and
Go up a little bit.
Go a little bit up. Yeah. Yeah. Now.
avow truth to the best of one's knowledge. Yeah, I agree.
Exactly.
Okay.
Are you agree?
Yeah.
Yeah. Thank you very much. And now we will give the floor to la amândoi să le dăm to both supervisors. Few minutes only about RAJAT. Yeah, we'll start with Professor Adelung. Please tell few words about person RAJAT.
Yes. Okay. very curious about science. He knows how to apply scientific methods in a very organized way. He likes scientific discussions. He is a good presenter, as we have seen today. He understood quickly scientific problems in scientific presentations. He can emphasize the most important points. He's very knowledgeable and has very good experimental skills as well. He's able to work also under constraints. So he did hard work in several laboratories in Moldova, but also at Synchrotron, for example, and at the laboratories here in Kiel. My opinion about RAJAT is that he's a very good and excellent researcher.
Thank you very much. Okay, now it's your time. Few words.
So I will say a few words about RAJAT, and so we have to say something about person RAJAT and about researcher RAJAT. When he came to Moldova, he was a new in our group, very forwarded young researcher, PhD student, so he went through a lot of documentation to come from India to Republic of Moldova. It was really difficult. At that time we even did not have embassy in so big country like India. Now we have it after RAJAT came. He is forwarded, is listening what advisors are suggesting, not always doing, because he has his own ideas, changing it the way, but in final it comes to a positive result. Good science, he was respecting the ethics, got a lot of courses here, attended all, learned really a lot. He got the whole support from our group and interacted with our students, with our senior researchers, with professors, and in my opinion he got really good experience. Now he is a well-prepared researcher and deserves this PhD, the joint degree PhD in physics from our university and from Professor Adi alongside. They will give PhD in engineering, so it's a joint award. He deserves it. He is well prepared, and I think every economy in the world they will take him for a good job. We also offered him a job here in the Republic of Moldova.
Okay,
Good luck.
Ladies and gentlemen, let me congratulate RAJAT. Okay, please help me. And welcome to our community of Doctor of Science. Okay. Yeah. Congratulations. Okay. And now let me finish our today section of this committee. Let me finish, but I would like to thank our colleagues from Germany, and it is very pleasant for us, even for me, as I am calling my small Berlin, and I hope Oleg Lupan is calling my small hill or something like this. We like Germany, and we like that this is the first joint diploma, and we hope we will extend our cooperation. Thank you very much for your efforts. Thank you very much for helping us. And this is a very nice experience, and I hope this group will extend and will teach our other group how to be in such a project and how to promote young people to remain in science. Thank you very much, and the section is, yes, this one.
Thank you very much from our side.
Your slides.
Yeah,
Honored, and it's very nice to work with you and have
your
a
slide.
joint degree in the framework of this European program. This is a premiere for us as well, so I'm very happy that we are part of this joint thesis degree with RAJAT.
Yeah, but now we give the floor to the RAJAT. Yeah, this is necessary.
First of all, thank you very much to all the attendees, to all the members who were invited, to all the online participants and whoever is present here physically. I want to acknowledge my professor, supervisor Dr. LUPAN Oleg at UTM and Professor Rețele at Kiel University, Germany for supporting me throughout my doctoral journey. Maybe there were a lot of odd and evens, ups and downs throughout my doctoral journey, but yes, definitely both the supervisors supported me throughout my doctoral journey. I want to thank the guidance committee members, Professor Arthur Buzdugan, Professor Nikolai Ababi, and Professor Vasile Kretsu for supporting me and discussing with me a lot of different aspects about science and also about Moldova. And the team of researchers from both the departments, MIB department at UTM and FunMem group at Faculty of Engineering, Kiel University. Thank you all. And the whole senior project members, special thanks to my family members, my fiance, my parents, my brother, and the whole Field Horizon team, especially Professor Rob Emelut for the nice collaborations, his student Masaya Subihara, who has provided us geolytic immunogenic framework, meta-organic frameworks to make it like a sensor. So thank you very much. And our industrial collaborators, Professor Dr. Engineer Yungitam Bhatt, Engineer Pomfajun Sivapum, and all the scientific collaborators who have contributed in our scientific publications. And maybe not, definitely there are a lot of people who have not contributed to the scientific publications, but they have supported me throughout my doctoral journey in directly or indirect way. All the bachelor students who have supported me today or making me comfortable throughout my doctoral journey, definitely at last, because at last they helped me a lot. And yeah, thank you very much.
The session, and I hope in 1 week you will prepare all the documents and will send to agency.